just start off by brainstorming, looking at different ideas. And then when I think about different ideas, I kind of cancel some of them out. Like, I don't like this idea right now, because if I make u sine x, then du is cos x, but in my original equation, cos x is inside of a square root. So I think I would probably tend more towards, I think I want to use u as cos x, and then du is negative sine x. So if I do that, if I let u equal cos x and du is negative sine x, well, I have no negative in my equation, so I'll pull that negative out to the other side. Now I want to rearrange this so that it could possibly work with u being cos x. The other thing, and the reason I think this is a little bit easier than the last one, is I see the inside of a square root cos x. So often we're choosing u to be a function inside of another function, right? And that's why it was also a very good possibility that u could be sine x, because technically the sine x is inside the power of 5. So both of those seem possible at this point in problem solving. But what I didn't like about making u sine x is that it didn't account for the square root. So now I'm going to rearrange. I'm going to take one of the sine x's and put it with dx, because then it matches up nicely and I can replace it with a negative du. So this, writing this inside the orange box is going to be nice because that will substitute with the negative du. That leaves me with a sine to the 4 and a cos x to the half. My sine to the 4, I can write as sine squared squared, which then I could replace the sine squared with 1 minus cos squared. This is nice, because if I replace cos x with u, then I have more substitutions that are possible. At this point, if I do all of my substitutions, I would have 1 minus u squared squared times u to the half times a negative du. And since we did a question yesterday, this is similar in that we can multiply this out by squaring it. We can distribute the u to the negative a half. And we're left with only powers of u. So each of these integrals are easy. Add 1 to the exponent and divide. Add 1 to the exponent and divide. And there was that negative that I had with the du, I factored out in front. And in my final answer, I just distributed that negative through each of them. So that's why the signs change on each one. And now we can substitute back. I also want you to notice in this one and in the previous one, our plan was to use our substitution to try to get to this moment where everything can be substituted out. In other words, if you're going to make u cos, we wanted as much things as possible in cos. In fact, everything needed to be in cos except for what we could substitute the du. Right? The du can get rid of one sign. So we know that du can get rid of one sign, then we need everything else in this question in cos. So let's start strategizing for the next one. And there's sort of two main things that you could do. These are your two main strategies that you can do. You're either going to make u secant x, or you're going to make u tan x. Because those are two derivatives you know. You can't make u tan squared x. Well, I guess technically you could, but you don't really know that derivative nicely. I guess that would be a third strategy if your first two strategies didn't work at all. Now fiddle around with those ones. If you use the first one or the second one, can you get rid of everything else and change everything else to something that would work? So what I'm going to do with both of these strategies is I'm going to rearrange my original function so that I have that derivative. So in the first one, if I make u secant x, I know that du is secant x tan x, so I rearrange my original integral to match that up. And I'll do the same thing for the other one. If I make u tan x, then du, I would have, I would still have tan cubed x and secant squared x, and that would leave me with secant squared x dx. All right. So, taking a look at both of those options, if I use option 1, where I change u to secant x, that will get rid of what's in the orange box. That could get rid of my secant x to be u cubed. Could I change tan squared to something with secant squared? Yes. So this makes me happy. Oh. This looks like it's going to work. Let's look at option 2. If I make u tan x, du would be secant squared x. So that's, I rewrite this by taking out a secant squared x. That would give me u cubed here with tan. Can I change secant squared x to tan squared x? Yes. Oh my goodness. double happy, they both work. We could choose either one of them. Doesn't often work that way that both of them work out. Usually something goes wrong with one of them that it doesn't quite work. But in this situation, here, you would have to change everything to secant squared. Here, you'd have to change everything to tan. Both are possible. So let's choose one of them. I'm going to go with the first one. If u is secant x tan x, if u is secant x, then their derivative is secant x tan x. I take my equation, I break things up so that I have here exactly what I did down there in my green strategizing problem solving. I get that secant x tan x by itself, and then I could change the tan squared to secant squared x minus 1. My substitution works out nicely. And we can distribute. Again, now u is just power, so we can add 1 to the exponent and divide, and substitute back in. Had you made your u tan x, you would get a correct answer as well, except your answer would be all in tangent rather than in secant. Okay. Now, if I were you and I was problem solving this on a test or the exam, chances are you choose your u to be something first. You either choose u as secant or u as tangent. And you would probably work through exactly what happens with that u. And if it works, you wouldn't try another option. You'd be like, oh, perfect. I just happened to pick the one that works right away. I'll just go with it. And then you solve the question and everything's fine. Right? It's just interesting in this one that both ways work. That secant x or tan x would have given you the right answer. All right, now, I don't know, would you classify yourself as I'm getting good at these yet? I'm not sure. Are they still extremely difficult? Yes, okay. Another one with tan and secant. So what makes it difficult? Well, you definitely need to know your identities from last year. That's super important. So if this is a moment where you're saying, ooh, I don't quite have all of those memorized, take the time to memorize them. When things come up where you need something from memory that you don't have, that's the best time to pause and memorize. I'm going to show both ideas. Oh, whoops. There we go. Secant x and tan x. there's the problem solving. I tried both ways. Tried making u secant x, tried making u tan x. Question is, and also in my problem solving, I know, like in the tan x one, I know that I could change any secant squared to equal tan squared x plus 1. And in the secant x one, I know that I could change any tan squared x, move that 1 over, to secant squared x minus 1. If we make u secant, then other than the orange box, everything else has to be secant. Can you see that we have a problem here? That I still have a tan, and I'm not able, only thing I can change tan to would be if I had a tan squared. I guess technically I could square root both sides. It would get messy, might work, but it doesn't work out nicely. So temporarily I'm like, I'm gonna put this one on hold because it doesn't look like it's going to work out nicely. I go to the second one, and in the second one, I would need to have everything in tan. So the question is, can I change that secant to the 4x to everything in tan? That works out nicely because every time I have a secant squared, I can change it to tan squared x plus 1. So I could change this secant to the 4 is really secant squared times secant squared. This one seems like it's a better option. The first one still might work if you would like, I'm going to write it out for you. If you square root both sides, you would have plus or minus secant squared x minus 1. That just looks messy to me. That looks messier to use with the plus or minus and the square root. This one looks a lot happier. So again, this is how you problem solve in these questions. You don't know the right way to do it. That's why it's a problem solving question. There's not something that screams, oh, I should make you this so much obvious. No, it's usually not that obvious. So you have to do a little preliminary work to see which one matches up better. Once you've done that preliminary work, I think I'm going to go u tan x. Now it's just a matter of rearranging, right? We want to separate out this. Put that in that orange box. Then since u is tan x, notice here that I changed the secant to the 4 to tan squared x plus 1. That's secant squared, all squared. Now I can substitute. Right? I have to do a little bit of algebra. I have to multiply that out. And then distribute the u squared. I'm sure you can do that. You'll get u to the 6th plus 2u to the 4th plus u squared. And substituting back, no problem. So we're using our technique of substitution, but then we have to also use our identities to make things work.